Hello, I'm Åke Sandgren from HPC2N in Umeå in Sweden. We've been doing EasyBuild since 2016. And basically, not going to talk too much about how we use EasyBuild, but what we install with EasyBuild and stuff like that, but rather how we get a clean room installation. We have two clusters, old bulldozer system that is technically already dead, but it's still running. We have a couple of different hardware architectures on the other cluster, which means that we really need to be able to build a lot of versions of the binaries. When we got the new cluster, Kebnekaise, we decided immediately that we need to use EasyBuild to handle this. We have, as you can see, 4 different architectures to deal with. And for ease of use, we went with HMNS as a module system. Easier for us, easier for the users in the long run. Also, we decided to have a single separate directory for each architecture and only display the current architecture, which means that we can easily use the default settings in EasyBuild, getting Arc Native and Xhost for intercompilers. Takes a bit more disk space, but who cares? It's free. The setup that we used to have in the beginning was that we installed everything in a path that basically separates the basic architecture, the operating system distribution version, and sub-level architecture, and a common directory with site local changes, easy configs, easy blocks, stuff like that. And we have a top-level prefix, which is to basically symlink into the correct architecture for each machine, which means that regardless of when you load your modules and you submit your job, the paths will be correct. Which is important because the Broadwell nodes and the Skylake nodes sit in the same partition. So a single job that requires multiple nodes may end up using both Skylake and Broadwell cores, unless you explicitly target one of them. Let's see. The installation originally ended up installing the software in our Lustre file system, and we did that with our own accounts and our own users. Lustre isn't really good at small files and lots of small files and data in this software distribution. Wasn't a problem in the beginning. We didn't have that much software. We only had like a couple of hundred packages, a couple of thousand versions in total. But this grew quite a lot. And in the beginning, we also we ran the installations on the login nodes, or explicitly dedicated a Skylake node for doing the installations. We had lots of development packages from the operating system because this was inherited from before EasyBuild. It makes it really hard to do clean builds. If we change the operating system installation, things broke. So, back to the solution for this. Compute Canada uses CVMFS, so can we. We were already using it for the VLCG stuff, for the LHC compute nodes. So we basically just moved the installation tree down to the CVMFS directory and redirected the link. Everything works. But since CVMFS is read-only, we need to build into the CVMFS master file system, which is an NFS mounted file system. We can't dedicate nodes explicitly for building because we don't have enough of them, especially the Skylake nodes, which we only have like 60 something. So we need a solution to handle that. Singularity, yay. So what we basically did, we made a minimal container that has the absolute minimum of software OS packages installed, which includes the InfiniBand development packages. We bind mount the NFS CVMFS master tree on top of the CVMFS mount point, which means that the container sees the actual NFS file system instead of the CVMFS tree. We bind mount the top directory, which means that the top prefix still points into the correct tree. When we are running on GPU nodes, we bind mount the NVIDIA and CUDA driver libraries so that tests can actually access the GPUs. And so we have a working container. We can build in it. It's absolutely clean. And the installation ends up in the correct architecture. We also changed this to have a single user doing the installations, because previously we had some problems with permissions. If Lars was doing the installation and I needed to change that installation, he owned the files, which meant the installation for me didn't work. With a single user doing this, there's no problem. It owns everything, and nobody else has access. We also made a small module that wraps the EasyBuild command to run the container to make everything simple. The only thing the container actually does is run a script from the outside, so it's easier for us to change it. Pure initialized environment loads the correct EasyBuild version and calls the actual EasyBuild with the correct arguments. And if the build finishes correctly, it also updates the L-node spider cache for that specific architecture. So everything is ready to be pushed when it's done. We still do the publishing into the CVMFS tree manually, because we want to make sure that we have built for both Broadwell and Skylake, so people don't accidentally see Broadwell software popping up, submitting jobs that ends up on the Skylake nodes, and there is no software there. So doing it that way, still slow, serial. We want to use the batch system to do this. So basically, if you just make a simple submit file that loads the EasyBuild wrapper module, we can submit jobs to whatever architecture we want, and it builds for the correct architecture, quickly, cleanly, good. But we want to use the nice Slurm dependency job building. Well, since EasyBuild just generates submit files that calls EB, if we have loaded our EasyBuild wrapper, the batch jobs that EasyBuild submits will still see that wrapper and run the container. Ah, nice. all this simply works when we run EasyBuild from the correct architecture. But we still need to build on the non-login node architecture like the Skylakes. So we combine the two. Combine the two, we write the submit file that targets whatever architecture we want, loads the EasyBuild wrapper, lets it run job, robot, and it will run on the correct architecture, resolve all the dependencies, looking at the NFS master tree, build everything, and everything is clean. There's no dependencies on the operating system except the absolute minimum that we have to have. And it works like a charm. I rebuilt the whole stack in, what is it, a couple of days, while actually changing this to make it work the way I wanted it to. We have like 400 different softwares installed, including libraries and compilers and stuff like that. In total, for all the architectures, we have about 5,000 different builds. These builds are very pure. There's no problems with both batch nodes and login nodes still have a shitload of operating system development packages and libraries and stuff installed. And with these builds, there's no problem. And if you want to look at what we actually did, we have it pushed it into Git repo. That's about it.
Any questions?
I have a question. So you're building and installing the software in this clean environment, and then you're giving it to the users who use it in a lesser, cleaner environment in terms of the actual system has packages installed in the OS and things like that. Have you ever run into problems where the software works fine in the clean room, but once you start using it outside of the clean room, it picks up other stuff from the OS?
No, not yet. And we are going to clean the environment, but we haven't gotten there yet.
Okay, because in testing contributions, things that we've seen is that sometimes EasyBuild picks up stuff from the OS and EasyBuild doesn't have a dependency and it works for one person, not for the other. But we also see the reverse, where if you have, Boost is one example, but there's others. If you have Boost in the OS, even though you also have Boost as an EasyBuild dependency, it breaks because it, for some reason, prefers the Boost in the OS somehow. That's during building, so there you're safe.
Yeah.
But I think there may be situations as well where a package that's installed in the OS somehow gets preference because of like hard-coded search paths in a Python script or I don't know what.
Yeah, but that's a problem with the actual code, but we haven't seen anyone.
Haven't seen it yet. Okay.
Not yet.
Yeah, if you plan to trim down the actual running environment as well.
We need to do that. We just haven't gotten around to it because it's been taking a bit of time to do this.
Yeah.
What is still lacking here, that we need a development tree for testing stuff and doing that, but we haven't gotten that far yet. The upside to this is that since we are doing a lot of development and using the development tree quite a lot, we can just load a version of that wrapper module that points to a specific specific development tree, either mine or ours, and we can have our own check out there and build into the production tree from the development tree
in a safe way.
In a safe way.
Yeah. Because I guess the software that EasyBuild sees, the already installed software that EasyBuild sees in the container is read-only. Or
no, in the container it has access to the NFS read-write tree. for the production.
But it's safe because you have the CVMFS thing where if some module will do rm-rf or some makefile will do rm-rf of everything, that will never actually make it to production because you will hopefully catch that before you do the publish. Yeah.
And we can just pull it back from the CVMFS tree.
Yeah, yeah.
Recreate the original copy. If necessary. Hope it never happens.
And before you publish to CVMFS, do you do more checking to make sure things are okay, other than making sure it's both Brother and Skylake?
Nah, not at the moment.
Yeah.
We need to do more, but
yeah,
we haven't had time to do.
like make sure only things have changed in the installation directories of what you were installing and not somewhere else. That things have not disappeared. I mean, there's lots of things you could check for.
Yeah, there's lots of things.
And we've had issues like this in the past where you install a Python package and you think it's going in the installation prefix, but it's actually being added to Python itself. And then you run into surprises.
We've seen that before.
Yeah.
But no, we haven't been checking that yet. But
you can.
we could because we during publishing we have a stamp file in the CVMFS tree. So we can actually check against that timestamp for files that have shown up. That's also what we use to figure out what to publish, what to rsync over to the CVMFS tree.
Yeah, really cool. Any more questions? No? Okay, let's continue. Thank you very much.